So the Riemann zeta function itself is very unique, very special. There's nothing like it. There's actually no equation in which you can increase the t number. You can have a duration, a length, and that is periodic and has this harmonic decline or asymptotic decline. Especially you can see that in the smaller t's is small enough, you can see it declining every nth. So you can imagine like like a tornado. I mean, or something that is periodic, that is increasing in height, in duration, in length. Doesn't have to be vertical increase, it could be horizontal. So T could represent that. And we're finding out at a point, what point is it that it comes very close, that the diameter, I could think of it as like the diameter, or has been significantly almost closing, and like almost there's like a knot has been formed, like it collapses, so there's no, the whole diameter collapses, so something like that, like it gets smaller and smaller, and that it collapses. So that kind of movement is nothing like it, but it's not perfect. And perhaps the real question is, can we actually find an equation? Can we actually improve this so that we can actually see it become zero? The modulus is zero, it collapses. Because so far there's no equation just like that with those features. Can it be improved so that at finite n the modulus is zero? Both cosine and sine collapses. Both cosine and sine become zero. Can it be done? Is, I think, the better question. Because right now, without truncation, without correction, without approximation, without assumptions, like, okay, this actually becomes zero, there's another calculation, we can do some corrective terms, and L can show you that at finite n it can become zero. But then that's actually like, you can't rely on modulus, because other sigma, there are actually t numbers and sigma combination that can produce a low modulus, 0.002. It can be done. So that argument that it's the true zeros, it's a misnomer. There is no true zero, and modulus itself is just a partial part of it. It is actually the periodicity, the how it declines, and in fact, pi over 2 is the pi over 2, like you can t times pi over 2 is an estimate for the valley or the deep. That's why even if in large numbers, I can just from the estimated n, I can just start from there, so I don't have to start at n equals 1. I can just start from there and see it declining, so you can kind of predict where it starts declining. But like I said, it's not the modulus. It's not just the modulus. You can't define it by modulus because it doesn't even equal to zero at any finite n. So it has to be defined in some other way, and it does, and it can be defined in some other way. It's the declining steps, something like that. But it's the equation itself is quite elegant. It's and there's so many applications to that, but there's no zero. there is no modulus equals 0. There's cosine and sine doesn't collapse. The wave doesn't collapse. It doesn't reach 0 given the known zeta zeros.